Hey everybody, this is going to be rough because I'm doing it on the fly. What I want to do is to write a simple program which in assembly language, which I will do on both Linux and the Macintosh. And I'll do the Linux version first and then convert it to native ARM usable on the Mac. Now, to show you what I've done for setup, I have Kimu running with my ARM virtual machine so that it is approximating what you have on Windows running in WSL. And then I have a shell which is logged into that virtual machine. And you see I've got nothing here. And then I have a shell, which is on my Mac, and there's also nothing there. So I'm going to start out by showing you what program I'm going to write. I'll say new file, and it'll be main.c, and create that, and include stdio.h and int main. I'm just going to, here's the whole program. It's going to be for int I equals 0, I not equal to 10, and I plus plus, and it's going to say printf, um, and it's going to give me some text, and then I'm having a placeholder for an integer. That'll be I. Print a new line, close the string, and then supply the integer itself. And close the for loop and return 0. And we're done. That's the program I'm going to write expressed in C. So let's see that run. This is kind of superfluous, but what the hell? I get paid by the hour. So GCC main.c and a.out. Okay, so that's what it's supposed to do. Now let's write it in assembly language. So new file, and this is for Linux. So P2 align, and that's going to align on a 2 to the power of 2. So that's going to align what comes next on an address that's divisible by 4. Here comes instructions, and I need to identify main as a global. And that's going to be different on the Mac version, but this is the Linux version. So here's main, and I'm always thinking about what can I do, what's the minimum I need to do in order to get to the next test. So the minimum I need to do to get to the next test is I'm going to move into W0. Now think of move as a copy. And I'm going to put a 0 in W0, and I'm going to return. And this will be the end of my program. Okay, I'm ready to test. Let me call this Linux -S. And let's go. Oh, gee, how do I get this over to Linux? Well, I got to make sure that I have installed an SFTP plugin, which I have. It's right here. Good, good. All right. Shut that down again. Go here. I'm typing in Command Shift P, which would be Control Shift P, and I've recently used this. The server's port is 2222, pre-configured. The username is just user, and this is going to go into // Let's call it for loop. And the upload on save has to be set to true. The OpenSSH is set to true, comma, uh, PASS, and there's password, and the password is a lowercase a. And now my SFTP is configured. Let's go to our remote machine and do an ls. There's still nothing there, but let me change anything here. I added a space, I took away a space, I'm hitting save. And let's look down here. And there you go. For loop is there. Let's go into the for loop and see what's there. Oh, Linux is there. So GCC, Linux, and run it. And there's my first test. Okay, so popping back up here, the next thing I want to add is taking care of the frame pointer and the link register. So I want to back those up. So that is STP store a pair. Thank you, no. Store a pair of registers. Which registers? X29 and X30. And where am I going to put them in memory? Well, it's going to be based relative to the stack pointer. And I want to manipulate the stack pointer by pre-decrementing it by 16 bytes. And that's the proper syntax. Okay. Now I want to recover them. LDP, X29 and X30. And I want to post increment after fetching those values relative to the stack pointer. Okay, I'm ready to do my next test. Save, build, run, still runs. Okay, I'm happy with that. Now, if you go back here, I've got a variable called I, and I'm a smart person, a human, and I'm going to dedicate one of my one of the registers I have that survive function calls, and I'm going to use X20. And by the way, I'm going to change this to be a long, just so that I'm using apples to apples. All right, so I changed I from an int to a long, and I'm going to come back here. I can close that, go away. So I can come back here, and I'm going to use X20, I said. So that's a single register. So it's not a P for pair, it's a single register, X20. But notice I still have to manipulate the stack in units of or multiples of 16. And LDR. And notice the order that I'm doing these operations. Once again, manipulating the stack in multiples of 16. So see how that's mirror imaged? 29 and 30 went on first to the stack, then 20. But coming off the stack, it's 20 first, then 29 and 30. All right. Now that's enough for me to do another test. Come down here. And okay, I'm still happy. I'm done working with my frame, with the stack. I'm going to set up the frame pointer, and I've just gotten in the habit of doing this. The Mac wants this. Debuggers want this. So I'll just go ahead and do it. And that would be a copy, which is called move. It's not really a move, it's a copy. And I'm going to put the present value of the stack pointer in X29. Now let's go over back here to the C, and this bottom here, when you reach the end of the loop, you already know that you have to go back to the top. So what is a closing brace in the for loop? It's a branch. It's a go-to. And where is it going to go? Well, there needs to be obviously two labels. Well, we could get away with, maybe we can get away with one, but we're going to write this naively, intuitively, and we need two labels. So we're going to need one at the top of the loop and then one at the bottom of the loop. Now, what I'm using here are just digits with a colon. The colon it declares it as a label, and using just small integers, these are temporary labels. They're ephemeral. In fact, you can reuse the same numbers over and over again. What you'll find in assembly language is that you have a lot of labels. So this is makes labeling really easy. Otherwise, you have to come up with unique names, and life's too short. So before we get into the loop, I need to set I to 0, or what I'm using as I to 0, I. So that would be a copy into X20 of the 0 register for X registers. So that is the equivalent of I equals 0. All right. And we'll write the for, oops, I got some extra spaces there. We'll write the for loop. So while I isn't 10, all right, well, not using I, we're using X20. So I'm going to compare X20 to 10. Now, the way a CMP instruction works is it is actually a subtraction. It subtracts the second argument from the first argument and throws away the results, but keeps information about the subtraction. For example, did the subtraction result in 0? So branch equal to 0, and here's where the bottom of the loop gets called. 2, and it's ahead of me, so 2 forward. Now the bottom of the loop is just going to be a branch to 1 backward. There's my closing brace. And if I run it now, I'm going to have an infinite loop. So I don't want to do that. And I'd have an infinite loop because I'm not changing X20. So let me do the equivalent of I plus plus. Only I'm using X20 because I'm a smart human. And let's see how you read this. This is another instruction where you read it right to left. So this says take 1, add it to X20, and put the results in X20. So here's a complete loop. It doesn't print anything, but now compare this to the for loop here. So initialize I to 0. Every step through the loop, add 1 to I, and stop when it reaches 10. So here I initialize X20 to 0. I will stop when I reach 10, and each time through the loop, I add 1. So this I can test. It's not going to output anything, but it will stop. I mean, that's a good thing. Boom, good. All right. Now let's do the printing portion. Okay, I'm not writing code now. I'm putting in data. So this is the data section. Printf requires a template string. Let's take a look here. So this is going to result in a char star. That's a pointer to a string as parameter 1. And then parameter 2 is a long. So it's, oh, geez, I got to figure this out for Mac. Ugh. Printf is a variadic function, and it's very different on the Mac. And since I'm doing this on the fly with no edits, I'm going to embarrass myself. So we can look forward to me cursing in a little while. Okay, so here's the template string. Or did I already curse? I can't remember. It comes so naturally to me. Number, and is that what I wrote in C? Yeah, number, and then printing out the number and a new line. This is a string sitting in memory at the address specified by the letters, the label FMT, and it's a null terminated string. That's good. What I'm about to do is set up the printf, which I'll do it the same way on the Mac, and then I'll modify it on the Mac. But this instruction's not allowed on the Macintosh. So I'm putting the value of the first parameter in x0, and that's the address of the string. And then I'm going to copy the second parameter into x1. And now I'm going to call printf. Then it's going to add 1 to x20 and branch back to the top of the loop. Let's try that. And this program is complete. That's on Linux. Oh boy. And now I have to redo this for the Macintosh. So let's see. I've got, now I'm going to copy linux.s to, I'll create a new file called apple.s, capital S. And now I need my Linux conversion, Apple Linux conversion macros. So let me go find that. So copy ASM book, macros, Apple here. Okay. So if you look now, I've got everything where it needs to be. So let me edit this and bring in the macros. Don't need a tab there. Apple Linux convergence dot s, and this is good. So now I've got the macros. Instead of global, it will be global for global label, and put my indentation back. I now need to make this a macro called main and get my indentation back. But there's one more thing to do on the Apple, and that is also for the debugger. That's a macro which sets up some state that says this is a function, et cetera, et cetera. And that has to be, you put that after the label for a function, and then you put end proc after the last instruction. All right, so since I have the macros here, I'm going to make my life a little bit easier. I'm going to say push a pair of registers, and notice I have less typing to do. So I like that. And this is going to be push R. Now that's not an ARM instruction. That is my macro. Whoops, that's a macro, which pushes a single register onto the stack. I also have the reverse. So pop R, and it just means less typing. In this case, it's more typing, but I wanted to demonstrate for you. Go here, get rid of that. Pop pair. And let's see, is there anything else down here that needs to change? Nope. Okay. Setting up the frame pointer is all good. This is fine. This is fine. This is fine. Here comes the first difference. And variadic functions are handled very, very differently on the Mac versus Linux. And you for a variadic function like printf, you actually have to write separate code. And I'm making this to only, I'll make this run on both machines. So I'm going to say if defined, let's see, is this how you do it again? If I forget how to do it, let me just look at the macros. That'll tell me. If defined, got it. If defined, Apple, do it one way, otherwise do it another way. Okay, so, and this is because of printf. Printf is variadic and it really, really gets upset if you do it the wrong way. So this is the Linux code, and here comes the Apple code, which would be load a local label. Um, Forgot what I called it. Let's look here. By the way, there's also documentation for these macros on the assembly language book. Okay, so here we are. Load, oh darn, I need more space in there because that's such a big mnemonic. I want that into be X0 and it's going to be FMT. Notice there's no, um, oh, this I could do outside I could do that here. Since I'm gonna make it work on both machines, so I don't need that. Uh, and this is going to be inside. So I've just done this. I see this is doing it for both Apple and Linux. It'll just do the right thing, so I don't need it anymore. This is needed on both. I said that I would set up for Linux, but then I would modify it. And this is going to come here. And this is going to be call the C runtime. And what I want is printf. But we're not done yet because of how for Linux we're actually done. So let me actually go back and test this on Linux. Um, but let me make it look pretty first. Whoops. I could be doing this, so let me do that. Okay. And that goes there. That goes there. These two lines can be done together, and then these lines can be done together. Okay. All right. Now, is there anything that would spoil this to run on Linux? So notice, folks, I'm going over to Linux, and I believe I can still build the Apple version because of my macros. Ooh, maybe not. Apple Linux convergence. Oh, I didn't squirt that over. So let me make a change, put it back, squirt it over, and it still works on Linux. And soon it will be working on the Mac. Let me go back to the Mac and go back to my code. Okay, so the very on the Mac, variadic functions, the very first parameter can stay in X0, but all the other uh, values have to go onto the stack. So I've got X1 is properly loaded up. So let me, here, folks, this is where I'm going to go wrong because I haven't quite mastered printf, the variadics on the Apple yet. So I'm going to try pushing one register, X1, onto the stack, call printf, and then pop one register. And you know what? I don't care about the value in X1, so I'm just going to add 16 to the stack register. Okay, because I don't need to go out to RAM and retrieve the value originally in X1 since that's a scratch register. So it's faster just to add 16 to the stack pointer. So let's try it. Now, folks, look, I'm on the Mac. So GCC Apple .s and oh boy, tell me I hit it the first time. Woohoo! That means I can end the video. Haha, cool. So, folks, you're looking at a very simple program, but using these macros I developed, I have written it in such a way that it will work on Apple ARM machine and on a Linux ARM machine using the same code. Now, before I close, let's look. The only weird, specific Appleism that I did here is push P and push R, pop P and pop R work on both Linux and on Apple. So I'm not going to explain that, but I will take a look at local load address and C runtime. So here is local load address. And if I use it on Linux, it's just what you've seen before. Puts an equal sign in front of the label. But if you do it on an Apple machine, it's going to load the page of the, excuse me, it's going to load the page of a containing the label, and I will explain that in class. And then it's finding the specific byte of the label within that page. So that's how Apple does the same thing. And then let's take a look at global. So on Linux, it says global label, but on Apple, it's global with the underscore label. Here's main. On Apple, it's underscore main. And on Linux, it's just main. And finally, CRT. That was what I used to branch link register, branch with link to a function. So on Linux, it's exactly BL to the label, but on the Apple machine, to call a label as part of the C runtime, CRT, C runtime, it's BL underscore label. And that's pretty cool. So it unifies everything. Thank you for watching a 29, and if I keep talking, it'll be exactly 30 minutes video, and I'll see you in class.